Well, and we were talking here just a minute ago. We had a pretty good conversation going on about, uh, your electricity, the quality of electricity and coming into your business.
Good evening, ProfitDig. I appreciate you guys tuning in. I'm here with Jeff Spencer. How you doing today, Jeff?
Man, how you doing, Jeff?
Man, doing pretty well. Thanks for tuning in. If you like the content on the channel, like, subscribe, share, all that good stuff. You know the game. We really appreciate any contributions you have, comments, maybe questions you have for us. We would love that. And if you're looking for a job bidding and costing solution for your construction company or really service industry of some type, check us out at ProfitDig.com. We've got a great tool there. We're real proud of it, and we'd like you guys to check it out if you've got a need for that type of thing.
If you want to make a donation, we have a Venmo account. So.
Oh, do you? Is that on your OnlyFans page?
Yeah, it is, yeah.
Okay,
Yeah.
all right.
No, just kidding. But
All
no,
right.
we appreciate the introduction, Jeff, and Jeff Gibbons here. He's over our IT stuff. He's a partner and as well, and Jeff has a pretty interesting line of work he does, and we don't talk about that very often. But you're an electrical engineer, correct?
I used to be. Now I manage.
Manage, okay.
I manage engineers that manage electricians.
Yes.
So,
Well, and we were talking here just a minute ago. We had a pretty good conversation going on about, your electricity, the quality of electricity and coming into your business, and what that looks like. And so, Jeff, like we was talking about a few minutes ago, what's the average, like, if you got a plant out here, that's getting ready to start up and they've got a need for electricity, to run some presses or whatever kind of machines they may have, what does it look like, as far as bringing raw power into a building like that?
yeah, it's an interesting topic because, obviously you've got energy generation, either whether it's through coal plants or nuclear plants or,
Right.
Hydroelectric or even solar farms, depending on where you're at. But all that gets injected into the grid.
Right.
Right. And in the U.S., there's actually three separate grids. There's two major grids, that cover most of the states. And then Texas has their own. I think it's called ERCOT. But they have their own unique electrical system. In fact, we saw that in the news a couple of years ago. There was some big fiasco down there. But actually, it's probably the nicest grid in the U.S.
Really?
They just had a unfortunate circumstance. But yeah, the generation of this power goes in based on the demand of, consumption of businesses, consumption of homes. And there's an expectation of once that energy is generated, that once it gets injected into the grid, it has to kind of line up with the demand of the grid. So depending on the amount of demand on that particular location of the grid, as well as the complexity of the electrical signals. So like if you just have nothing but light bulbs, from a technical perspective, that just looks like resistors.
Right.
And there's not a lot of complication there. But once you start including things that are nonlinear sources of, or require nonlinear sources of power, so like drives and motors, things, even computers, electrical equipment, things that have like a non-consistent demand, it really starts to wreak havoc on the quality of power that goes into the grid and then eventually comes to either your business or your home. And so they refer to this quality of power as power factor.
Yeah, we were talking about that a minute ago, and you were talking about how, power, as far as electrical power, is not always clean. It's not like it can, it has to be monitored by the government, correct?
Yeah, well, definitely there is an auditing process for the major utility companies, but it's not just that they need to be audited. Companies, especially, when they sign an agreement with a particular energy provider, they have expectations on their internal power factor as well. Because what this means is, imagine I've got a warehouse and I'm running some, I don't know, assembly lines in this warehouse, you know, if I don't take care of my business, and I'm at like a good power factor is like, and it depends on where you're at, but you know, point 0.8, it's all based on a scale or a percentage base. You can look at it a decimal from 0 to 1, or you could look at it percentage from 0 to 100. A point 0.8 is like bare minimum, right? Like, and even then, like, you're going to get fined in the U.S. if you're at that range. But
Okay.
typically, you'll see different municipalities will have a recommendation of 0.9 or even 0.95, depending on, like, if it's a data center or something like that. They have higher requirements because of the amount of power they're taking. They're going to impact the demand on that grid more than, like, you know, you at your house.
Right.
And most of the things in your house aren't really that complicated anyways, because it's a lot of lights, and really about the most complicated thing you're going to have at your house is going to be something like a dishwasher or AC. Yeah. Something that's going to be maybe pulling different, anything with a motor in it, especially.
So what about machines in general, like as far as a surge? I know you have a kick-on surge, you know, for you, it draws you power, and then all of a sudden you got a boost of power that goes back to your system.
So, yeah, that depends on the different type of equipment. So mostly you'll see surges under normal circumstances with motors, and when you go out into like different factories, especially, or hospitals, things like that, a lot of times, unless it's a really basic motor with a basic function, you'll see not only a motor, you'll see something which they refer to as a drive associated with that. Or if there's not a drive, then there'll be something like a soft starter, something to
Absorb that.
absorb, or like you said, the inrush current for turning on a big motor takes a lot of current really quickly.
And then
And
the
with a
system has to try to step up to compensate for that, doesn't it?
It does, yeah, and that's why, and if you're pulling it in one particular machine, it's a finite amount of energy, right? So if you're pulling the majority here on maybe a huge motor, I don't know if you got a turbine at a factory or something like a big motor. If you're not careful about turning that turbine on with either a drive or soft start or even something more complex than that, then yeah, for sure, that energy that you demand to start that turbine, because it always takes more just to get it started than it does when it's in some type of, not perpetual motion, but once it has some consistent velocity to it. They call that an inrush current, and that will pull from other areas, either locally or depending on how the grid's laid up, like you may affect the plant next
I was
door.
gonna say, you see your neighbor's lights go out over there, you know?
Yeah, you see
Right.
you see it damming up the lights, and
Yeah.
you even see this at your house when sometimes the air conditioner kicks on, like, you know, depending on the building. Hopefully your house doesn't see that, but you do see that demand. But then there's also like non-standard surges, which could mean like where you have some type of short in your system, and you know, a short. When you look at what a short is in terms of current, you know, power is just current and voltage multiplied together, multiplied by your power factor.
Right.
You know, like that's really basic understanding of it. But when you look at what a short does, is it removes any resistance from the system. So it tries to pull as much current at one time as it's instantaneously capable to do. So when we talk about something shorting out, that's why oftentimes it creates like a fire, because you've got a copper wire that's trying to pull in an infinite amount of current. And what does that inrush of energy and power convert to? Converts to heat. Yes. And so when you have something like a short, especially if it's something that can pull a lot of energy, like maybe that turbine we just talked about, usually you have protection devices in your facility. You should have protection devices that will trip when it recognizes that. If you don't have either the right equipment or haven't done what's called a coordination study on your facility, then coordination study goes in, and it takes someone to do the analysis. They're still done by hand even today,
Really?
signed off by professional engineers. But they dictate what those protection settings should be based on the requirements of your facility. And when they put their stamp on it, they're saying, look, I promise you, if these conditions are met, like a short circuit condition, this protection scheme will protect your downstream equipment and being realistic, even loss of life, right? Like, because some of this equipment, when it fails, it doesn't fail gracefully usually, right? If it's a short circuit.
Well, and I've got one more question before we close. I know we're getting close on our time stuff here, but like we were talking about the clean energy, you know, or the clean power coming in. We talked about it briefly just a minute ago, but just to give everybody a better understanding, like how can that affect if it's not, say it's a 0.8 or lower a chance, how will that affect your devices inside that are in need for power?
So the most basic impact is that, you know, if you've got, I don't know, a laptop, for example. My laptop's got batteries, so that's a bad example. You got a desktop computer that you've got plugged up. It requires so many watts,
Yeah,
right? And if the quality of the power being injected or being pulled into that home by that one device is not met, it won't operate properly, right? And the ramifications of that could be as basic as, oh, well, it just won't turn on. Or if it operates in a condition that it's not supposed to, it could actually damage the
that's what I
internal
wanted to ask you, if
components.
it was a longevity issue, you know, as far as,
It definitely could impact, well, and especially when you talk about rotating machines, like we were talking about motors earlier, you know,
because they have to get to a certain point to where they can run efficiently.
that's right.
And if they don't reach that, they're always in a strain, correct?
Oh, that's correct.
Yeah,
Yeah.
okay.
So, you know, there's lots of things that could happen, but also what you're paying for. You're paying for clean energy,
Right.
and if you weren't getting it, you'd still pay for the energy that you draw, whether it's clean or unclean.
Right.
Right. So, having that guarantee that, you know, you're going to have an acceptable power factor. Every piece of equipment has a tolerance.
Yeah.
You know, they can run it
That's
instead
what
of
I was wondering.
120 volts. Like oftentimes you'll hear 110 volts, or
Yeah.
you know, they could even go sometimes, depending on the equipment, as high as 130 volts, and that's the acceptable range based on the deviance in the voltages. And the same for the current. Like they expect a pull of 0.7 under normal, 0.7 amps under normal operation, but maybe you could get by with 0.6, you know, for a very, very limited time,
Yeah.
just to keep some circuitry going. But when we're talking about electricity, oftentimes the conversation is in, you know, milliseconds or microseconds of how long you can sustain a condition like that.
Yeah. But like, one more thing, you know, like same subject. Say you got this big electric motor. The life expectancy should be like, you know, I'm just throwing a number out there, say 20 years. 10 years down the road, it goes out, goes bad, out of warranty. Is there any possibility that could be from power not being par? You know, can it sustain that long? You know, say, you know, 0.8 is minimum. We'll say it's like 0.79. You know, or something like that. I don't know what the figures will be, but you know, just it's not getting quite what it needs. It works properly, does everything it's supposed to do, but you've cut its life expectancy in half. Because is that a possibility?
Yeah, it's a possibility, but typically power factor is not going to impact a motor compared to some of the more common failure conditions for motors are much more mechanical oriented. So like you've got, you know, inside your motor, you've got rotors and stators, you know, what allows it to turn, right, with their mounted magnets. You'll have something like bearings that could fail, the lubrication inside the bearings. So typically what you see for motors is going to be a failure based on the mechanical portions of it. Now, there's ways to monitor those failure conditions to try to either predict when it would fail in the future, or to at least have an early warning sign before it fully fails. But you're right. I mean, a lower power factor definitely could cause an impact on the quality and the overall health of that motor, and other devices really could reduce the life expectancy.
All right, guys. Jeff, appreciate it, buddy. Some interesting stuff, and I'd like to talk to you more about it too. You know,
Yeah.
it kind of intrigues me a little bit. But guys, we thank y'all for tuning in. Like we said earlier, you know, if y'all enjoy our stuff, please like and share a comment. Go to ProfitDig.com, check us out. World's easiest bidding and job costing software. Try us out. Thank you.